Hello, in this video we will be seeing how to find the maximum area of a piece of cake given that we want to put vertical cuts and horizontal cuts using a knife into this cake, and we will be also finding the time complexity and space complexity of the solution that we will be building in JavaScript. Before jumping into the solution aspect of it, let us first try to get a quick understanding of what the problem statement is. So we are given a cake which is represented by this matrix, and we will be putting cuts into this cake with a knife, and we can either put cuts vertically or we can put the cuts horizontally, and each block in this cake is represented by an area of 1. So this is 1, this is 1, all these blocks are 1. And what we have to do is, after we put some cuts into this cake which can be either horizontal or vertical. So let's say in this example we received input of horizontal cuts as 1, 2 and 4, which is represented by this red horizontal cut against 1, then against 2 and against 4. And similarly we will be also putting vertical cuts. In this example it is 1, 3. So you put a vertical cut here at 1 position and you put a vertical cut at 3 position here. So this is what the problem statement is, and after we put these cuts we want to find the biggest area of a cake that we can pick up and eat. In this example, as you can visually see here, you have a cut here, you have a cut here, you have a cut here and a cut here, and this area forms the largest area, which is 1, 2, 3, 4 blocks. So the output of this is going to be 4. And I can also try to find some smaller areas. For instance, you see this one, this is like a cut here, a cut here, cut here, cut here. So this is 2. Similarly, you have a cut here, 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 and this is the border. So this also comes into consideration. So this is also 2. So you see, these are smaller pieces, and this is the biggest piece that we could find. And that's pretty much it in terms of what we are given in terms of constraints. We also get H, which is basically the number of rows in the matrix that we have, and W, which is the number of columns in the matrix that we have. And we have to return this in number format, this final output, which is going to be the area. And to find the area, what we can basically break down this into is, how did we get this 4? So this cut, this from this 2 up to this 4 had an area of 2, which was 4 minus 2. So this is 4 minus 2, which is 2, this cut. And similarly this cut between this vertical and this vertical was also 2. And how did we get this 2? Was we took this cut of 3 and with this cut of 1, and we did 3 minus 1, which was 2. So we took cuts on the horizontal side, we took cuts on the vertical side, we found the difference between the two cuts that we considered. So we said 4 minus 2, this one minus this one gives us the gap between these two cuts to find the gap that will be our cake. And similarly vertically we will take the difference between this one and this one to find this gap, that is 2 here, and we just multiply these two gaps, which is going to give us 4. So what we basically did was, we found the maximum horizontal gap and we multiplied it by the maximum vertical gap, which were basically our cuts that were formed. After the cuts were put, whatever the maximum area we could find, we just multiplied them on vertical and horizontal sides. And that is the core of our solution going to be. We will just find the maximum in my horizontal cuts, we will find the maximum in my vertical cuts, and we will just multiply it and return it. And that's going to be our solution. But please note that there is one more constraint here, that this input that we receive is not going to be sorted. So to be able to apply this logic of saying this, let's make my current cut here, and if I do my previous cut minus here, so 4 minus 2. So if this was I, let's say this is my I minus 1. So to just consider this logic of doing 4 minus 2, which is my I minus 1, I have to make sure they will also be sorted. Otherwise, if I do I minus 1 and this was not in sorted order, my logic won't stand to reach a solution. And that's how we will reach a solution now. And this will just translate into code something like this. So we said the input is unsorted. So first thing I'll do is just sort my input, and I will just do something like this, and this should sort. Then I will do vertical cuts dot sort also, so a minus b here also. And after I have sorted my input, I said I will find the max horizontally, the biggest piece that I can find horizontally, and then the biggest piece I can find vertically also. So I will keep a tracker here, max horizontal cut, I will say 0, then let max vertical cut, I will also say 0, and in the end what I'm going to do is multiply this maximum horizontal cut and my maximum vertical cut and just return it. This will be tweaked a bit later on, but I will come to that later. First we will just focus on the core of the solution. Then we said we want to make sure that we find the biggest horizontal gap. Now how did we find? Let us retrace. We had a horizontal cuts input here. We took this 4, we said 4 minus 2. So if this was I, this was a I minus 1. I found the difference between these two, and similarly I could have also found the difference between these two. So this is 2 minus 1 gives me 1 on this side between this gap and this gap. So this was not our maximum, and what we want to do is we want to keep doing this and just pick up the maximum cut that we find. And to do that we will just use a loop. But before going into the loop aspect of it, we also have to take another factor into consideration related to the problem statement. The problem statement also states that here in this horizontal cuts array, when we get this 1 basically means from the top of the matrix or the cake, this being a cake representation of a matrix, this 1 basically translates to the distance from the top of the cake. And the input array doesn't have the top of the cake, it just has the distance from the top of the cake. So we need to make sure we take the entire cake into consideration, wherein here we are right now just taking from here to here, which might not always give us the correct output. In this example it was fine because we did like 4 minus 2, but we need to consider the entire cake horizontally. And to consider the entire cake horizontally, this basically means that before this we had this top, which was basically 0, and after this 4 we have this, which is basically this 5. So it goes from 0 up to whatever h we received here, which basically translates to something like horizontal cuts dot unshift 0. So I just put a 0 at the start to consider like from the start of the cake and not just from some mid point from the input of horizontal cuts that we receive. And similarly, we will also say just push h that we receive. So this will push 0 and 5 into this array of ours, and now we will try to find the maximum cut that we can possibly find, and that will just look something like this. So we will start with 1 because for the 0th position we put a 0, so we don't need to start from there because we basically follow this logic of this I and I minus 1, we find the difference. If I start from 0, it is 0 minus 1, minus 1 is out of bounds. So we start from I will go from I up to the length of my horizontal cuts, which is going to be something like this, and I will say give me the gap or the piece of the cake horizontally, which will just be something like horizontal cuts of I minus horizontal cuts of I minus 1, which we basically did here in the earlier representation that we followed, saying 4 minus 2, and this was 4 and this was 2. So the current minus previous, that is what we follow, and we are doing this in a iteration. So we first find the difference and then we are keeping this max horizontal cuts tracker. So we will just say here this is mat.max of the max value that we already had and this ref. So we will keep iterating and try to get the biggest gap. We get this gap also, and then we get this gap also, and then we will see this is the biggest horizontal cut gap that we find, and then we will just use that one. And similarly, the same thing is going to be done also for our vertical cuts, which we have, and then we will say our max vertical cut is going to be the difference between my current max, which is the tracker here, and then we just keep this difference that we have with us. So current minus previous, which is basically 3 minus 1 in this case. And we missed out one thing, which is for the horizontal cuts, when we found, we put this boundary and this boundary. Similarly, for the vertical cuts, we have to take this boundary that we have and this boundary also that we have, which will basically translate into something like this. So we will say our vertical cuts dot unshift with a 0 and vertical cuts dot unshift push with a W, which is the bound of our vertical cuts that we have, number of columns that we receive. Basically same thing we did for horizontal cuts, we are replicating it for the vertical cuts. This is nothing new, and we ran an iteration to find the max horizontal cut. Similarly, we ran an iteration to find the max vertical cut, and we are just going to multiply these two and return. Now just one catch here before we return. We want to return a number in the end, so I will just say I want to give back a number, and these inputs can be quite large, and I don't want to go out of bounds for our test cases because then the test cases might fail. So I will just give a begin representation for both of this, and then what I will do is I will mod it with a big prime number. So I will just say mat.power of this, and then I will just do here, I will say 10, 9, plus 7. So this is a big prime number, and this will make sure that the number doesn't go out of bounds after we multiply, and then we just do a mod with this bigger prime number here. So this is not the largest prime number, but this is like the biggest prime number, which will make sure things don't go out of bounds. And usually this is used inside technical solutions whenever we want to make sure we don't go out of bounds during algo interviews and stuff. And that's pretty much it in terms of our solution. We just find the max horizontal cut, max vertical cut, and we just return whatever we have. That's pretty much it. And this also needs to be taken to make sure we don't, because this is going to be quite a large number. This can also be quite a large number. So we want to make sure we are able to process these numbers, and then we will just cast it into a number in the end and return. And in terms of time complexity, what will happen is, this is sorting logic. So let's say we have this horizontal cuts with h as the number of rows. So this will be log of h in terms of the time complexity, because sorting is going to take time based on how many inputs you have, and then accordingly this is going to be h.log of h. So this always, when we consider the sorting time complexity, it will be h.log of h that we have. And then what's going to happen next is, for our vertical cuts also, we're going to have sorting complexity again. Let's say it is represented by w, so it's going to be w log of w, and then we go into this loop here, which is going to be time complexity of big O of h here. And similarly, the time complexity of this loop is going to be big O of w. So the overall time complexity that we will have here is going to be h log of h and plus w log of w, because we add both of this together and here, this one and this one. And in terms of space complexity, what we did here was just use this 2 tracker here, and we just wanted to find the maximum. We are not using a lot of space here, so it's just going to be big O of 1 in terms of a space complexity that we have. So this is the overall time complexity, and this is the overall space complexity, which is big O of 1. And that's pretty much it in terms of our solution that we have. Thank you for watching. Please like and subscribe.